Hello, Science 9. We are on polyatomic ions part 3 today. I want you to remember that you are not expected to memorize the PAIs, the polyatomic ions, formulas, or names. You will get a chart with all of these. So why am I telling you all of these patterns about the names? So for example, last day, if you remember, we learned about 8 compounds. And then if we put a bi in front of it, what it means is that we're adding an H plus ion to it. Okay, why am I bothering to teach you that? You'll just be able to look up carbonate and bicarbonate on your chart. It's just because at some point, it's really nice to have these things lock into your memory. That's not going to be this year. It might be grade 10, it might be a grade 11, it might be grade 12, it might be university. But if you know that these patterns exist, then you'll have a much easier time remembering them over the course of the next few years. But remember, you don't need to memorize them right now. So what we're going to look at today is we are going to start with looking at the difference between an 8 ion and an 8 ion. Okay, so if we look at these two formulas, ClO3 negative and ClO2 negative, we can see that they have some things in common. They are both -1. Okay, we have a -1 charge and we have a -1 charge. So if you have something that is a chlorate or a chlorite, they will have the same charge as each other. The one thing that is different is the number of oxygens. Okay, the number of oxygens is different. And ite ions have one less oxygen than 8 ions. Now, wouldn't you love it if I said something like, oh yeah, all the 8 ions have 3 oxygens? I'm sorry, I cannot do that. That isn't the case when you get to something like sulfate, it's SO4. 8, the 8 ion is simply the most common oxy ion that belongs to a particular element. In this case, it's chlorine. The most common of the chlorine oxy ions, those that contain oxygen, the most common one is chlorate. Okay, the 8 ion is the most common. Of the oxy ions. Oxy anions, actually. And what is an oxy anion? An oxy anion is one which has an element plus oxygen. And all your oxy anions are going to end in ate or ite. All oxy anions end in ate or ite. But we run into a little problem because there's more versions of chlorine-based oxy anions. We don't just have the 3 and the 2. We also have oxy anions based on chlorine that have 4 oxygens and 1 oxygen. You see there's no subscript there, there's a 1. So what happens is we add on some prefixes. Okay, so if you have one more oxygen than the 8, okay, you add the prefix per. So one more oxygen than the plain old 8 ion, we use the prefix per. The prefix per comes from the same root as super. Okay, so if you have a Superman, he is more than a man. He can jump tall buildings, leap tall buildings in a single bound. That is more than a normal man can do. That would be superman. Okay, so per means more than. So a perchlorate ion has more oxygen atoms than the chlorate ion. Perchlorate has more than chlorate. Now, hypo, if you think of the word hypothermic, that means your body temperature is below its normal temperature. If you get a hypodermic needle, that means that that needle is going to go under your skin. Okay, that's what hypo means, is below. Oh, by the way, dermis, that's the technical scientific term for skin. So hypodermic means below the skin or under the skin. And so if we use that prefix, if we have one less oxygen than the ite ion, we use hypo. Okay, so ClO has one less oxygen than ClO2. So we're going to use the prefix hypo, one less oxygen than chlorite. Okay, hypochlorite has one less oxygen than chlorite. Remember, you don't need to memorize this, but it's nice to know all those little prefixes because they will come up later in different contexts. Okay, you are now going to use these names and formulas as a pattern, okay, to name these ions down here. And you'll notice that I have given you chlorine-based oxyanions. And remember, chlorine is a halogen. Okay, so what I want you to do is I want you to pause the video right now, and for yourself, I'm going to erase those, they're kind of ugly, you are going to write the name of BrO4 minus, BrO3 minus, etc. Okay, so take a moment and name all of those ions. Okay, hopefully you saw the pattern and you had paused the video to give yourself time. When we have the perchlorate, that is analogous to, it is similar to BrO4 minus, so that would be bromate. Not bromate, it would be perbromate. Okay, ClO3 minus was chlorate, so BrO3 minus would be bromate. One less oxygen than an 8 ion is our ite ion, so we would go from bromate with 3 oxygens to bromite with 2 oxygens. And then one less oxygen again, that's one less than the ite, would be hypo. bromite. Let's name our iodine-based oxyanions, and we're going to start with our most common one, which is the iodate. How do I know it's the most common one? Because all of my halogens are in the same group, therefore they behave chemically very similarly, so they will form similar ions. So chlorate has O3, iodate has O3. One more than the 8, we have to put a per in front because per means more than, so that's per iodate. One less than 8, the 8 ion is ite, so that's going to be iodite for IO2 minus. And finally, hypoiodite has one less, or it has one oxygen below or less than the iodite. Okay, you can pause the video now again and you can answer these two questions. If SO4 2 minus is sulfate, what is the name of SO3 2 minus? And I almost said the name, but I stopped myself. If PO4 3 minus is phosphate, what is the name of PO3 3 minus? Pause your video and answer for yourself. Okay, SO3 has one less oxygen than the 8, so we're going to change the ending to ite. So SO3 is sulfite. And don't forget, if you want to spell it sulfite, that is okay. All right, this is the British way, and this is American. We're Canadian, so we can do either. Okay. PO4 is phosphate, so one less oxygen would give us phosphite. This one you cannot use an F.